Welcome to my class Physics Untold. Here I am representing a question from Problems in Physics for IIT-JEE Advanced, and this is from SBT, and this is from level number 3, problem number 141. So let's start the question. In the figure, all pulleys P1, P2, P3 are massless and all the blocks 1, 2, 3 are identical, each having mass m. Here in our question it is described that there are a number of pulleys such that pulley P1, P2, P3 all are massless, and the blocks, and there are blocks as block 1, block 2, block 3, etc. are identical, each having mass m. The system consists of infinite number of pulleys and blocks. Strings are light and inextensible, and horizontal surface are smooth. Pulley P1 is moved to left. Now this pulley P1, which is moves towards the left side with constant acceleration a0, or pulley P1 is moving with a constant acceleration a0 in the left side. Find the acceleration of block 1. Assume the string to remain horizontal. Now first of all, if we analyze this question, in this question it is given to us that there is pulley mass system, and in this system there are 3 pulleys are shown here, that is pulley number 1, pulley number 2, pulley number 3, etc. And there are masses such as block 1, block 2, block 3 all are connected with the pulley number 1, pulley number 2, pulley number 3, etc. But this system is increasing infinitely, or this is an infinite pulley system. And here all the blocks are identical. Here the identical meaning of the identical pulleys mean its mass of all the blocks are identical or equal. The system consists of infinite number of pulleys and blocks. Strings are light and extensible. So here one thing is to be noted, that the strings are light and inextensible. If the string is not inextensible, or if the strings are extensible, then the strings acts like a spring. But in this case it is inextensible, therefore it will acts like an ideal string. And horizontal surfaces are smooth, and all the surfaces on which the block are placed are smooth. Here the significance of the smooth surface is there is no friction, or in the entire problem there is no friction between the surface and the blocks. Now this pulley P1 is moved towards left with constant acceleration a0. We have to find the acceleration of block 1, assuming the systems to remain horizontal. So this is the diagram by which we can calculate, or we can assume our prediction as per which is asked in our question. So here in this diagram there is a pulley P1, there is a pulley P2, there is a pulley P3, and the tension between the pulley P2 and P3 is T2. Tension between the pulley and the block 3, pulley P2 and the block 3 is equal to T2. Tension between the pulley P1 and P2 is T1. Tension between the pulley P1 and mass M1 is T1, etc. Now let us consider the problem in the reference frame moving to left with an acceleration a0, which means if we move the system is moving with an acceleration of a0, or let's consider the problem in the reference frame moving to left with an acceleration a0. Therefore the total system is accelerating with a acceleration a0. Now we can fix this pulley P1. So in this frame P1 P1 is at rest and all the blocks experiences a force m0 towards right. That is, this is our block number 1, this is our block number 2, this is our block number 3, and in this case this pulley P1 is at rest. So if we consider the pulley is at rest, then this block 1, block 2, block 3 all will experience a opposite force, a pseudo force, which is acting in the opposite direction of the applied direction of the acceleration, or there will be a pseudo acceleration experience in this case. So this is our tension T1, which is tension between the pulley P1 and pulley P2, and this is our this blue colored line is indicating the tension, and let the pulley P2 is moving with an acceleration a0. Let us consider the pulley P2 is moving with an acceleration a0 in the leftward direction. So if the pulley is moving in the leftward direction, and as we are seeing from the diagram that its acceleration a0 is towards the left, and its tension of the string is equal to T1, and which are on the same line and the same direction. Therefore, we can clearly conclude that our tension T1 is directly proportional to a0. This is our equation number 1. Now, if the block in this frame, let the acceleration of block 1 be a1 in the leftward direction. So here is our block number 1, which is accelerating with an acceleration a1 in the leftward direction. It is shown in our diagram. So this arrow is indicating the direction of the acceleration of block 1 and its direction, which is a1, and its direction is towards the left. Now if we consider about if you think about the pulley P2, then we can say there is a tension of the pulley which is equal to T2, or there is a acceleration of the pulley, as there is a acceleration of the pulley P2 in rightward direction. So its acceleration is a1, because here the applied acceleration, or the acceleration experienced by the block 1 is a1, now which is acting in the leftward direction. Therefore, there will be a pseudo, so it may be considered as a real or applied acceleration. So there will be a pseudo acceleration which will appear on the pulley number P2, which will act just in the opposite direction of the applied acceleration a1, or here the real acceleration can be assumed as a0, and the pseudo acceleration can be assumed as a1 for the case of pulley P2. Now pulley P2 will move towards right with an acceleration a1, because as the block 1 is directly connected with P2, and the block is moving with an acceleration in the leftward direction. If the block is moving with an acceleration a1 in the leftward direction, and the string which passes over pulley P1 is directly joined with the pulley P2. Now as the block 1 is moved in the leftward direction, therefore its acceleration or the pulley P2 will shift in the rightward direction, or we can say the pulley P2 will move towards right with an acceleration at A1. So this is due to the force appeared on block number 1. Now if an observer is located in reference frame attached to P2, suppose there is an observer who is located in the reference frame to P2, then what he will observe? From his observation point of view, there will, which is moving to left with an acceleration a0 minus a1, because suppose there is an observer who is located in the reference frame to P2. So if the observer is located in the reference frame of P2, then he will observe that which is moving to the left with the acceleration a0 minus a1, because observer is on the reference frame of P2, and there is the acceleration of the pulley in the leftward direction, which is a0, and the rightward acceleration of the pulley is a1. Therefore the net acceleration will be a0 minus a1, because as a whole, because our applied, in our question it is mentioned that our applied acceleration is towards the left direction, or therefore the net shifting or net acceleration of the pulley P2 will shift in the leftward direction, but its magnitude will be the resultant of the accelerations between the acceleration a0 and a1, or we can say, which is, if an observer is located in frame attached to P2 which is moving to left with an acceleration of a0 minus a1, then we can indicate here there is a tension of the string. Let this tension of the string is equal to, now from this diagram, this tension is equal to T1, this tension equal to T2, again this tension is equal to T2. So all these tensions are given here. So we can say that the net tension developed on this segment of the string. The net tension developed on this segment of the string is T2, because for the connecting strings, there is a string which is connecting pulley P3, which is passing over pulley P2, and which is again attached with the mass 2 or block 2. Or here the tension is T2. Tension of this segment of the string is equal to T2, and this tension is obviously proportional to the net acceleration of the pulley P2. Or we can say, or we can conclude here that our tension T2 is proportional to the magnitude of the acceleration or which is a0 minus a1, or simply we can say T2 is proportional, this T2 tension is proportional to its opposite acceleration a1 minus the acceleration in the direction of the tension. Or in other words, we can say that as there is a tension is developed which is equal to T2, and the acceleration in the direction of the tension is a1, and acceleration in the opposite direction of tension T2 is a1. Therefore the net acceleration in the direction of the tension T2, which is equal to a0 minus a1, which must be proportional to the magnitude of the tension T2. Let this is our equation number 2. Now if we divide this equation number 1, which from equation number we already got the value of T1 or proportionality of T1. Now from equation number 1 we can write here the T1. T1 is proportional to A0, and from equation number 2 T2 is proportional to A0 minus A1. If we divide this equation number 1 by equation number 2, then we can get the ratio T1 divided by T2 must be equal to A0 divided by A0 minus A1. But the pulley is massless. It is mentioned in our question that all the pulleys are massless. If all the pulleys are massless, then what will happen? Then there will be no contribution of the motion in the no mass contribution of the motion in the entire system for pulleys. Therefore, we can simply balance the tension of the strings for the left side of the string tensions and right side string tensions. And if we take, there is a tension T1 and let this tension is equal to T2 and this tension is again T2. So these two tensions are acting directly towards left, and which is acting on the pulley which is passing over the pulley P2. And again the pulley P2 is connected with a string which is passing over the pulley P1 whose tension is T1. So if we think about up to this segment, from this segment this T1 must be equal to 2 times this T1 plus this T1, or we can simply say that this T1 or this tension must be equal to sum of this tension and this tension, that is equal to T2, or we can say T1 equal to 2 T2. Now if we calculate this, then we'll get the value T1 divided by T2, which is equal to 2. Now we can substitute the value of T1 by T2 as 2, and we can say, or equating these equations, we can write A0 divided by A0 minus A1 equal to 2. Now if we recalculate this equation, then there will be 2A0 minus 2A1, which is equal to A0, or we can say A0 equal to 2A1. So this is the relation between the acceleration A0 and A1, and which we found out as A0 equal to 2 times A1. But in the ground reference frame, the acceleration of the block will be acceleration of the applied acceleration, which is already provided in our system, which is equal to A0, and it is in addition with another acceleration which is already find out, which is equal to A1 for the block 1. Now as we already find out that the relation between A0 and A1 is A0 equal to 2 times A1, or we can say A1 equal to A0 divided by 2. Therefore the net acceleration must be equal to sum of these two individual accelerations, or in a nutshell we can say in the ground frame the acceleration of block 1 will be A0, which is the applied acceleration, and the another acceleration which is obviously appeared by applying the tension in the strings or pulling the systems, that is equal to A1, or net acceleration of the system in the ground frame, or in ground frame acceleration of block 1 will be sum of these two acceleration, which is equal to A0 plus A1, and value of A0 is A0 and value of A1 equal to A0 divided by 2. So if we sum these two accelerations, then we'll get the net acceleration of the system will be, or net acceleration of the block 1 must be equal to 3 A0 divided by 2, and which must move in the leftward direction. Thanks for watching this video. Like, subscribe and share for more videos like this. Thank you.